have to worry about nothing.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we don't have to worry about nothing because we're doing the mathematics. Specifically, we're doing the beloved trigonometric problem solving. Trigonometry is in our future. Isn't that wonderful? Let's get right to it, shall we? Thank you, Miss Ellie Golding. Here's some nice examples of some trig drawings. I bet you can't wait. Let's start with a ladder leaning against a wall. Want to? The ladder is of length 4.1 meters. And there's the ladder right there. And then the top of the ladder is 3.5 meters from the ground. So I have the ground down here. Yes. And then right here, you can't see very well on that brick, I know is 3.5. And I know that because from here to here is 3.5, so it has to be the same height. Anytime they say a vertical wall, you can assume that it is a right angle. So part A says, find the angle the ladder makes with the ground. So that would be this angle right here, and I'm going to call it theta. So I'm going to use right triangle trig, and I just ask myself, what's the relationship of the sides I know or am looking for in relation to theta? So that is the opposite side, and I'm just writing out here because it doesn't show up well on the brick. And this is next to, and you might think adjacent, but it's the hypotenuse, and hypotenuse trumps adjacent every time. What trig function uses opposite and adjacent? Well, that would be sine. I know that the sine of any angle is equal to the length of the opposite side over the length of the hypotenuse, which in this case, sine of theta is going to equal 3.5 over 4.1. Okay, and then I'm going to say that theta is equal to the arc sine, which is the same as the inverse sine of 3.5 over 4.1. In fact, I'll even write it, you can write it like this, or this inverse sine of 3.5 over 4.1. And I wrote arc sine because the calculator I'm using today is the online calculator at desmos.com. And so I'm going to do right in here, and I need a function. There's arc sine, and I need 3.5 over 4.1. And I get 1.022. And as you know, that doesn't seem right just for the lengths of the ladder and the wall and everything. But Desmos always starts off in radians, so I need to check in any case to make sure that we're in degrees. And then it changes to something reasonable, 58.6 degrees. So theta is equal to 58.6 degrees. So that was part A, pretty simple, I hope. Part B, the distance from the foot of the ladder, that's right here, to the wall, right here. So I'm going to call that x since that's what they're asking me to find. Now, they say using trig, and I really don't have to use trig because I could use the Pythagorean theorem. I have the hypotenuse and another leg of the right triangle, but they asked me to use trig, okay? So I now know that theta is equal to, and I'll put this in here, 58.6 degrees. 58.6 degrees. Okay, so I can use that to find x. What's the relationship between the angle and this side? Well, it is adjacent. So I'm going to write that as adjacent, ADJ. Okay, and then I can either use the opposite or the hypotenuse, both of which I know. So if I use opposite and adjacent, I would say that the tangent of 58.6 degrees is equal to the opposite length, 3.5, over the adjacent length, x. Or, if I didn't want to use those two, I could use adjacent and hypotenuse, which is cosine. And I could say the cosine of 58.6 degrees is equal to adjacent, x, what I'm looking for, over 4.1. Now, this equation here is probably the easiest to solve. We would multiply both sides by 4.1, and we would solve for x. But this is the first one I chose, so I'm going to use it. Plus, sometimes you don't have a choice, and I know sometimes you don't like it when x is in the denominator. No big whoop. I'm going to multiply both sides by x here, and the x's cancel because they are equal to 1, x over x. So now I have x tangent 58.6 is equal to 3.5. And I'm solving for x, so I'm going to divide both sides by the tangent of 58.6. And that's degrees. I'm just too lazy to write the degree symbol. This cancels out because it's equal to 1. And so x equals 3.5 divided by the tangent of 58.6 degrees. So let's see what that equals. We'll go to our calculator right here. So that's going to be 3.5 divided by function tangent 58.6. You don't have to worry about degrees because it's all done already when we did it the first time. And rounding to the nearest tenth, we're going to get 2.1 meters, which seems reasonable given the other lengths. So this will be 2.1. And you would get the exact same thing if you solved using the cosine relationship. Doesn't matter which one you use. I just wanted to show you the one where you have to do it's a little bit harder because sometimes you don't have a choice. Next one. A tree casts a shadow 6 meters long when the sun is at an elevation of 70 degrees. Well, let's draw that right away. So we have a tree. Here's our tree. And then we have it's a blue sun today, boys and girls. And it's shining down this way. And so my shadow is going to be right here. This is the shadow. If you can imagine the sun shining here this way, this would be the shadow. And at some point, like right through the middle of the tree to the top of the tree, we're going to be at a right angle with the ground. And it tells us that the shadow is 6 meters long and the elevation is 70 degrees. So we have a nice picture here. Okay. A gardener wishes to fell the tree. That means chop it down at ground level. So they're going to like right at the ground here. Right at the ground. They're going to take a chainsaw and go whoop, right there. And needs to cut the trunk into 4-meter lengths to cart it away. How many cuts must he make? Well, I don't know how many cuts he must make unless I know the height of the tree. So I'm going to call this little t for tree and solve for t. Or I guess I could put the t here. Maybe that's a little bit less confusing. Because if I know the height, I know how many cuts I'll have to make, depending on how long it is. And so I look here, and this is opposite the angle. That's what I'm looking for. And I know the adjacent side, and it's adjacent because it's next to it, but not the hypotenuse. Here's the hypotenuse. I don't need it this time, but I'll go ahead and label it anyway. So I'm using opposite and adjacent, so that means I'm going to use tangent. So the tangent of 70 degrees is equal to t over 6. So to solve that, I'll do that in pink. I'm going to multiply both sides by 6 because the 6's cancel since 6 over 6 is equal to 1. This is a sideways 1, by the way. So 6 multiplied by the tangent of 70 degrees is equal to t. So let's go to our calculator, and we'll go 6 functions. You can put in multiplication if you want to. You don't have to. 6 tan, and that was 70 degrees, and I get 16.5 right here, rounding to the nearest tenth, right? So t is equal to 16.5, and that is meters, I believe. Yep, 16.5 meters is equal to t. So it's asking how many cuts do I have to do to make 4 4-meter lengths. So I've got a tree that is 16.5 meters from end to end, and it's on the ground, and I have to cut it, right? So I would have to do like 4, and then 8, and then 12, and then 16, and I would have a little bit left. So how many cuts is that? 1, 2, 3, 4. So the answer to this question is 4 cuts. All right, I hope you enjoyed that. We'll go out with a little bit more of Ellie, see how she's doing here. Move this out of the way, and we'll play, and I think she's going to be letting it burn, burn, burn. All right, hope you enjoyed it. I am... Oh!